This video will introduce you to our xTOAPI framework. In this video, we will highlight the Winform Controls, how they are used in our plugins, and how they are used when creating instances in a model. Though we have an extensive framework to help create complex plugins, the form controls are the heart of it. This framework saves a lot of development and programming time. We will be using our recently completed railing plugin for one of our larger projects to demonstrate these controls. This plugin creates railings with picket type panels. The input is a polyline and the railings are created following the polyline around corners and up or down slopes. We will be demonstrating the controls in our dialog as they are used to collect information from the user from several different tabs. This plugin was created in Visual Studio 2019 from our plugin template. As you can see, there are several Winform controls in our framework that we use. We will be showing and discussing most of these and demonstrating how they work in the development environment and in a Tekla model. Included are several types of controls for the .NET Data Grid View control. The controls are added to the forms like any other Winform control. We will start with the bolt control. The bolt control has one custom property, the on property. The bolt control can be toggled on and off in the Visual Studio development environment. You can see a visual representation of the current state of the on property. Let's look at how you can interact with this control in the Tekla modeling environment. Single clicking on the control toggles the on property from true to false and back again. Shift clicking on the control opens a bolt dialog for setting all the bolt properties for this instance of a bolt group. In this dialog, you can load pre-saved bolt settings from your modeling, project, or firm settings. Holding the control button down, you can drag and drop to copy the settings from one bolt control to another one. You can also use the copy and paste buttons in the bolt dialog to copy the settings. All the bolt settings can be set just like in the Tekla UI Bolt Properties dialog or property pane. These properties do not need any additional programming to be used in the Visual Studio development environment, but are added automatically by the framework when a control is added to the form. The bolt item control is generally not used on a form, but it is used in the framework's bolt dialog. It ties the bolt standard with the available bolt diameters in the current model environment. We will review the data grid controls later. The distance list text is a control for gathering distance data in either the metric or imperial environments. Here we can see the custom properties available in the Visual Studio development environment. There are different settings for the imperial and metric environments for setting the format and the precision. For the imperial environment, we can choose inches or feet in inches. We can choose whether to see a leading zero, we can choose the fractional precision from 1 to 128ths of an inch, and we can choose whether the inch mark is shown or not. For the metric environment, we can choose the precision or number of places shown after the decimal, and whether we see zeros after the decimal or not. All these properties can be set by the user when they are interacting with the plugin dialogs. These are set using a context menu where you right-click in the control, the menu pops up. Holding the control key down, you can drag and drop the values in a distance list text to another one in the dialog. Distance texts have the same properties and can be used and set in the same way as distance list texts. In the development environment, we see the same set of custom properties in the distance text as we saw in the distance list text. The next control is the double text. It is used for getting and setting double values in a dialog, for example, angular dimensions. This plugin does not have any of those types of controls required, so we will add one and review the custom properties. Here we see just two properties, the precision and trailing zeros. These also can be changed in a dialog when open in the modeling environment. There is also an integer text control which we will add to the dialog. There are no custom properties for this control, and it only accepts the minus key and integer keys as input. The material button control can be used to open a material dialog. We don't use this by itself, but it is used in the material text button control. This control we don't use in a dialog either, but we do use it in the part properties dialog and in the data grid view material editing control. In the part dialog, which we can open by shift-clicking on a part control, we see a material button control, which when clicked on opens the select material dialog. In our part data grid, we have a material column which contains material text button controls. We can edit the material in these cells also. Simply click in the cell and then click on the button on the right with the ellipsis to open the Select Material dialog. The rows in a part data grid are linked to a part control, and updates made in one show up in the other. This is done with one line of code, which we will see later in this video. Next is the part control and part data grid, but we will come back to those and look at the profile button and profile text button controls first. These controls are very similar to the material button controls, but open a profile dialog instead of a material dialog. Clicking on a part control and then on the profile button in the part dialog, we see the select profile dialog. This dialog is modeled after the one in the Tekla UI and can read in the same rules and organizations as in the model environment. Selecting the profile updates the profile text box. In the part data grid, there is a profile column. If we click on a cell in this column and then click on the button with the ellipsis, we will also see the select profile dialog. Again, we see that changing something in the part data grid also updates the values in the part control. Now let's review the part control and the part data grid. In our dialogs, we place all of the part controls and the part data grid on the Materials tab. The part data grid uses a lot of our custom data grid view controls. We put the part data grid on one side of a splitter control and the part controls on another. The part controls have three custom properties in the development environment. Here you can control whether the beam, column, or contour plate attribute file load buttons are to be shown in the part dialog while in the modeling environment. Some controls might need the beam properties, some might need the column properties, some might need both, and some might need the contour plate properties. In the development environment, we can add part controls to rows in the part data grid control. We do this in the form shown event. For each part control, we add a row by passing in a part control to the add row method in the part data grid. This links each row to a part control so that their data stays synchronized with each row. The Boolean Combo Box returns a true or false value. This is intended to use only two lines or rows of choices. If the first row is chosen, it returns true if the second false. You can specify whatever text you want shown in the rows of the combo box. There is one custom property called the bool value, which can be set in the IDE properties or from code. The combo box control is like the Microsoft combo box with a collection of items. We will show this in a future video that goes more in depth in the framework. The picture box control allows a selection from an array of images. There are several custom properties for this control. The thumbnail images property is a collection of images that are displayed in an image selection dialog when the control is clicked on in the dialog at runtime. The pictures property is a collection of images that are displayed in the control both at runtime and design time. There is no limit to the number of images for either collection or to the size of the images. Dialog title is the text displayed in the title of the image chooser dialog displayed when the control is clicked on at runtime. Disable interaction when set to true will also disable the opening of the image chooser dialog at runtime. Number of columns determines how many columns of images may be displayed in the image chooser dialog. The column width and row height affect the size of the image chooser dialog. Clicking on the picture control opens the image chooser dialog to select an image. Using the mouse scroll wheel changes the image also. In code, the return value is an integer index of the image chosen from the list of images. The text box control is included for use with the framework code generator, which we will see later. The weld control is like the bolt control and part controls. Like the bolt control, it has a custom property on to toggle the state of the control. Typically in our plugins, we use the on property to determine whether to create the weld in the model. This allows the user to control when welds are created. Single clicking on a weld control in the dialog at runtime toggles it on or off. Shift clicking opens the weld dialog. In this dialog, you can load pre-saved weld attribute files in the model environment for use in the plugin. All the weld properties are available and can be set in this graphic dialog. Like the bolt and part controls, you can drag and drop welds to copy settings from one weld control to another using the control key. You can also use the copy and paste buttons in the dialog to copy weld settings. We will take a quick look at the data grid view controls included in our collection. We use these in the part data grid as we saw earlier with the material text editing control and the profile text editing control. There are also several number-based editing controls including the distance, distance list, double, and integer. These number controls can be used in a column, but they can also be used in individual cells in a data grid view that has a number column in it. We use this in our profile selection dialog for parametric profiles. In this example, we see where there are some distance values or properties and some double values or properties. The value column uses a number column, and in code, each row is created using either a data grid view distance editing control, data grid view integer editing control, or a data grid view double editing control for the value cell. Also in the part data grid, we see the material text editing control, and in the columns for the start numbers for assemblies and parts, we use the data grid view integer editing control column. The part data grid is a predefined data grid view with all the columns set up, and it can be used simply by dropping it on your form like any other control. All the properties and pop-up dialogues are available without any coding. The description column comes from the part controls when they are created and linked to part properties in the framework. We are going to look at how the framework makes this so easy to use these controls and to create powerful forms. This railing example dialog has a lot of information in it, but because of the framework, the code behind it for the form is only 104 lines long, and only 40 of those lines were added by the plugin programmer. The other 60 were created by the template. This is all made possible by the part of our framework we call the configuration editor. In this editor, we can set all the bolt, weld, and part properties and dialogues like the ones that pop up at runtime. We can also set other properties and options. To link the properties with the dialog at design time, we copy the prefix from the property and use it to name the control. For bolts, the control name would start with bolt and end with the prefix. The associated checkbox control name would start with the CK and end with the prefix. We do the same for weld controls. The control would start with weld and end with prefix. Likewise with parts. The part control would start with part and end with the prefix. Properties can be distance, distanceless, double, integer, Boolean, or text. The default values can be used in the plugin run method if the user does not input any values. These can be used for the distance list, distance, integer, double, text, combo box, Boolean combo box, and picture controls. Options are like properties but are not linked to any controls. They are more like advanced options in Tekla. This plugin does not use any options. We will create a new part property in the editor and in the dialog to show how easy the editor makes plugin creation and editing. The plugin properties have some values that are used by the framework for linking the defaults file created by the editor to the plugin at runtime. These values are used in the app.config file. We will look further at this in future videos. The configuration editor has one more important function, which is the scaffolding. This is a code generator that creates all the code necessary for using the property values both at design time and at runtime. Opening the scaffolding settings links the current plugin project to the configuration editor and lets us define where the 4 classes it creates are located. We can save the settings for later use in the plugin. Running the scaffolding creates those files using all the properties we have set for the plugin. We can see all the classes the editor has created for us. We will create a part property in the editor and a part control in the dialog to show how powerful this is. First, we add the description. This description is used by the framework in the part data grid and in the tooltip for the part control. We will copy the prefix to use in the form. We will copy some values from another part property for our example control. Now we will create the part control on our form. We need to name it to link it to the default file and the code that the editor generates. Next, we run the scaffolding again with the new part. After opening our main railing class, we will see how the attributes class property, which is a plugin property class, has all the properties we created using the configuration editor. If we choose the part property, we will see all the parts from the editor, including our example part, and we will also see all the part attributes associated with a part for us to use in our code. We have a code structure that we use in our plugins. This includes some standard base classes and interfaces. The lowest level is the interface iPlugin object that defines the property root parent that has a reference to the main plugin class. The abstract base class plugin object implements the iPlugin object interface, defines the create method, and has the parent and root parent properties, along with an instance of the attributes, which are the plugin properties created by the configuration editor. We inherit from this class for all plugin classes that want access to the attributes for their use. The plugin part class inherits from the plugin object class and has additional properties and methods related to creating parts in a model. We inherit from this class for all plugin classes that create parts like beams, polybeams, and contour plates. This class allows us to create a part in the model with one line of code. For example, this post class inherits from the plugin part class, and in its create part method, it creates a position variable and calls the create sBeam base class method, passing in the part properties from our editor, the start and end points for the beam part, and the position variable. There are some additional methods in this class to cut the part and add a base plate. The framework contains other classes and methods for modifying parts and getting information from part profiles. The post baseplate class also inherits from plugin part. It stores the post as its parent. In this way, each class in the plugin can access a hierarchy of objects above it. The baseplate class contains a baseplate data class with all the properties needed to create it from the dialog. Another class, the first post baseplate data class, inherits from the baseplate data and assigns values to each property from our plugin properties class created by the configuration editor. All the attributes in our plugins are nullable instead of using default values like Tekla plugin attributes in the OAPI. They also have a method getValue or default for assigning them to non-nullable types. All the different properties are available: bolts, welds, parts, properties, and options. We also use the factory design pattern often in our plugins. Here we have a factory for creating post data classes based on the position of the post in the railing, first, intermediate, or last. Though this video is lengthy, it only scratches the surface of the capabilities of our framework. The attribute types we saw as being available in the plugin code can also be available in the form code behind. We will show this functionality and other nice features of the framework in future videos, including how the framework enables nested plugins and even plugins nested in plugins nested in plugins. Thank you for watching. And click on the link here at the end of the video to find out more information from our website.